This is a sort of book release of my recent translation of Proclus's Elements of Physics. Proclus was, of course, the head of the Academy of Plato in the 4th, 5th century AD, and is most known for the commentaries which he composed on the dialogues of Plato. But he was the head of the academy at a time when the project was to synthesize the doctrines of Aristotle and Plato, or to resolve them, or to see them as being surface level oppositions, which upon examination may lead to a deeper understanding of many of the doctrines of Plato. This work entitled The Elements of Physics, regards Aristotle's physics, but looks not like a commentary, is almost the inverse of a commentary. Instead of composing a commentary on Aristotle's physics, Proclus extracted certain arguments which he found to be most central in Aristotle's physics and arranged them into a sequence of axiomatic proofs, of demonstrative proofs drawn from certain axioms. After the manner of Euclid's Elements, which he was most likely consciously imitating. Though Euclid's Elements is a sort of performance of what Aristotle describes in his posterior analytics. In any case, we find a rationalist project of physics. There are certain epistemological value, even aside from interest in Aristotelian physics or in Platonism and Aristotelianism or in ancient philosophy. Here we find something of epistemological value in his arranging certain arguments from Aristotle's physics into a demonstrative axiomatic science, a deductive science from axioms, much like Euclid's Elements. Proclus, mind you, wrote a beautiful commentary on Euclid's Elements, which we only have the first book of. And Proclus also composed a work that is not a commentary, one of his independent works called The Elements of Theology. So this is the sort of counterpart to Proclus's Elements of Theology, which is that sort of deductive, demonstrative, axiomatic sequence of theorems. This is the counterpart of his Elements of Theology, I think. Hence the Elements of Physics, modeled in a great part after Euclid's Elements. Now, I should express what else is valuable about Proclus's Elements of Physics. Aristotle's physics is a lengthy and difficult work. And we are benefited by being presented with a more simplified presentation of Aristotelian physics. Aristotle's physics is a very lengthy and difficult work that covers a variety of concepts and arguments that are very long-winded. It's hard to read Aristotle's physics and boil that down to a core sequence of arguments, or boil that down to something less long-winded, basically. And that is just what Proclus does. He basically extracts 50 or so arguments that Aristotle makes in that work and arranges them in that sort of sequential form from certain axioms. But what's interesting is that he takes the axioms from the 6th book of Aristotle's physics, and more than half of the theorems are drawn from the 6th book of Aristotle's physics, which is the least discussed part of Aristotelian physics. Usually in secondary literature on Aristotelian physics and in lectures on the topic, Book 6 and the arguments and the content of Book 6 aren't even mentioned. Usually what is discussed is Aristotle's general conception of nature, his general concept of nature, and certain concepts inherent therein, such as those of capacity and actuality, and matter and form. And well, in Proclus's Elements of Physics, those issues aren't even really present. You might say they're inherent, or that they may briefly arise in a couple places, but how Aristotelian physics is usually presented is not what we find in Proclus's Elements of Physics. And when Aristotle's physics is described and written about, the arguments in Book 6 are easily the least discussed. And that is admitted. That is always sort of stated by anybody who writes about anything in Book 6 of the physics, that these things are not often discussed. And for one, they are neither are they the sort of points which modern physics, early modern physics, was wont to contend against. This isn't the sort of presentation of Aristotelian physics that is familiar to us. And this was surprising to me, that he drew from the 6th book of Aristotle's physics, which is the most difficult part of that work. Richard Sorabji, the collector of a great number of commentaries, of translations of ancient commentators on Aristotle, calls Book 6 Aristotle at his best. These are not, Book 6 is not the part of the physics which you want to contend with. So it is surprising and interesting that Proclus draws the axioms for a science of motion from there, and more than half of the theorems from that book of Aristotle's Physics, which is the least known and is the most difficult and is quote unquote Aristotle at his best. My impression upon finding this was that Proclus is exemplary in that respect, in the question that's quite different from physics, which regards identifying the starting points and the end point of physics. I find this to be something which modern physics has always been weak in that respect. Here we see what physics looks like through the eyes of a philosopher, which really shows the wisdom of Proclus. That really only a philosopher could have stood out in that respect as to what the subject matter of physics is, what are its starting points, and what its ending point. That is, as Euclid composed a demonstrative axiomatic science of geometry. His purpose was to prove of the regular figures what their essential attributes are. Very different from modern mathematics, actually. But that's not the point being made here. The telos of the subject of geometry in Euclid's Elements is the regular figures, the Platonic solids. Euclid's Elements culminates in the Platonic solids. We might ask, as Proclus must have, what then is the telos of physics? What are the sorts of Platonic solids of physics which as Euclid's Elements culminates in those, a science of motion would culminate in? And for Proclus, as well as for Aristotle, the answer is the unmoved mover, the principle, the first principle of motion. For consider, we are dealing with a science of motion. This book is entitled The Elements of Physics, but is subtitled On Motion. So given that this is a science of motion, or that a physics is after a sort of science of motion, a physics that doesn't ascertain or establish any principle of motion is certainly lacking. That is why Aristotle's physics ends in Book 8 with the proof of the unmoved mover, the proof of the existence of the unmoved mover. Because that cannot be established. Obviously, the first principle of motion is required for a science of motion to be complete. But the existence of the unmoved mover cannot be established immediately. Has to only mediatedly be reached through intermediate theorems. And so is rightly the telos of the subject matter of physics or of motion. Thus, physics is seen as a bridge to the metaphysical, and deliberately so. Being the sort of telos of the subject matter. And the axioms are metaphysical too. For the geometer takes it as self-evident that a line is infinitely divisible into smaller and smaller line segments. That's a sort of, that's not proved in geometry, but is assumed. Where that is proved, those are the very first theorems of this work establish that by proof, that things continuous are infinitely divisible, that time being continuous is infinitely divisible, as motion also is infinitely divisible, being something continuous. That is the role of the philosopher, to supply geometry and physics and the other theoretical sciences with their starting points, with their axioms, by figuring out how to prove them universally without regard to that subject matter specifically. And Proclus really stands out in that respect. There is no more simple presentation of physics, of a rationalist physics. Mind you, Isaac Newton's Principia Mathematica was a sort of demonstrative science, or was performing an axiomatic science of deductive geometric proofs, but does not have the sort of overview of the subject matter and arranging the subject matter in order of importance, which a philosopher might, such as Proclus or Aristotle. That is something in which modern physics is lacking. It's very much the advantage of Aristotle and Proclus. If we look at the first principles or the starting points of quantum mechanics or of Newtonian or of Einsteinian physics or of Newtonian mechanics, from Newton to Einstein to quantum mechanics, we find more obscurities, more complexities, less of an intuitive sense of what simple elements can the composite statements that we want to prove be inferred from. Proclus is exemplary in that respect in this book, drawing the of establishing where the starting points and where the end points of the subject matter of physics or of a science of nature, of science of motion are. And in the sixth book, what surprised me was that I didn't notice that in the sixth book of Aristotle's Physics were the beginnings and the starting points of a sort of science of motion. But the Neoplatonist commentator Simplicius points out to us that Aristotle's physics, as we know it, was really composed of two separate books, and that the first considered nature more generally. Hence, those are the things that are usually written about and discussed in lectures on Aristotle's physics, this general concept of nature, matter and form, potency and act, or capacity and actuality. While the second half of Aristotle's physics was an entirely different work entitled On Motion. And indeed, we find that in book 6, Aristotle really shifts into gear, so to speak. We do find a set of axiomatic definitions, somewhat without regard to the first half of the physics. Though that stuff does arrange a sort of framework. Nonetheless, there are sort of axiomatic definitions in the beginning of book 6 of the physics, from which certain conclusions are drawn directly, which themselves act as premises of further syllogisms, and so on to the more composite and more composite and more difficult. And this is the part of Aristotle's physics which is usually passed over. Even when I first read Aristotle's physics, I sort of glossed over its resolutions of the paradoxes of Zeno. Very difficult, formal, almost technical. Semi-geometrical. I would call them semi-formal. But they're difficult. They're not easy reading. And you can see just from the table of contents. Here are the table of contents. I should say that the entire, this is split into two books. The first book corresponds roughly with the sixth book of Aristotle's Physics, with questions such as whether motion is continuous or discrete, whether anything can move at an instant, and theorems relevant to those. While the second book corresponds with the beginning of Aristotle's On the Heavens and his eighth book of the Physics. ultimately aimed at establishing the existence of the unmoved mover. Those are the two parts. And indeed, we do find two sequences of arguments in Aristotle's physics, which in book 6 start from the definitions of continuity of the continuous, contiguous, or touching to be in contact, and consecutive, or following in sequence after one another. From those definitions, a sequence of theorems are proved, each with a concise, semi-formal, syllogistic proof. Some of them even geometrical. Then there's a second sequence of proofs. In the 8th book of Aristotle's Physics and the beginning of his On the Heavens, in which proofs ultimately, another sequence of proofs ultimately result in that of the unmoved mover and the eternity of the circular motion of the luminaries. Thus, these parts of Aristotle where we find these arguments are much more, to use a contemporary term, rigorous. These are very rigorous proofs compared to what we find in much of the rest of the physics. It shows Aristotle as a master of argumentation, of all those syllogistic modes which he outlined in the Organon being put into practice. Thus, in the beginning of book 1 of this work, The Elements of Physics, we find those three key definitions: the continuous, contiguous or touching to be in contact, and sequence, following in sequence or consecutive, one after another. From those, he demonstrates in order, each with an accompanying concise, semi-formal proof that one, the first theorem is that two indivisibles cannot come into contact or touch, that 2 points cannot touch. From that, he proves the second theorem, that neither can two indivisibles compose anything continuous, that if they can't touch, neither then can two indivisibles compose anything continuous of any magnitude. And the third theorem, in anything continuous between indivisibles, there is always an interval, else they would touch, which they cannot, as has been established. And we will go over these. I will show you what these arguments look like. He means by that theorem that between any 2 points on a line, there must be an interval of length. Then the next theorem, that two indivisibles cannot be consecutive or in sequence one after another, because if there must be something continuous, if there must be some interval between any two indivisibles, then they cannot be consecutive or in sequence one after another. For the interval between them can be divided at a point, and then that point would be between the two indivisibles. But what is consecutive is defined as those things between which there is nothing of the same kind, but we can always find a point between any 2 points on a line. Then his next theorem is that everything continuous is divisible into parts, always divisible. That everything continuous is infinitely divisible. And from the table of contents here, you can tell that these are sort of independent from much of the first 4 books of the physics. Or much of the things that people speak of as an explanation of Aristotelian physics. And what Proclus does is he rearranges the argument, or he formalizes them, or he makes them better. Because we find this sequence of arguments in the 6th book of Aristotle's Physics. Within a discourse that is not just isolated proofs, but is accompanied by explanations, raises different topics, goes to speak about those, talks about other views. There's too much going on in Aristotle's physics. So that when you get to the 6th book and you see this sequence of difficult arguments that isn't even presented as a sequence. It's difficult to tell what he's even doing there, or that portion of the physics was meant to be the starting points of a science of motion. And again, these are not the sorts of things, much of the content of the first book is not anything which the natural philosophers of the scientific revolution were objecting to. There are a couple of things in there that would be objected to, but most of these would not. That again, after everything continuous being infinitely divisible, after that theorem, he proves that if a magnitude or distance consists of indivisible parts, the motion through it will also be made up of indivisible parts. Then if a motion consists of indivisible parts, the time of the motion will also consist of indivisible parts. Then, and that is all related to the same infinite divisibility of the continuous. He's just showing that if one of these things, either distance, motion, and time must all be infinitely divisible, or they must be composed of indivisibles. Either they're all composed of indivisibles or none of them are. Then he proves things like of things that move with unequal velocities, the swifter moves a greater distance than the slower in an equal time. And if there be things that move with unequal velocities, the swifter will move a greater distance and the slower a lesser distance, while the swifter will move that greater distance in less time and the slower in more time. Then of things that move with unequal velocities, the swifter and less time moves the same distance. Then he circles back and proves that all time, all magnitude, and all motion are divisible ad infinitum. The first 11 proofs regard that, the infinite divisibility of the continuum. Then he proves that an infinite distance cannot be traversed in a finite time. Notice that that's from Zeno's argument. Notice that he's proving almost the punchline of Zeno's argument, yet resolves the paradoxes of Zeno. He still uses aspects of Zeno's paradoxes almost as resolving Zeno's paradoxes. He retains even certain arguments, even the complete argument of one of them and part of the argument of the other of them, or changes the context of them after resolving that there may still be motion. Then those are sort of the grounding of his science of motion. Perhaps in a separate video, I will go into some of these theorems to give you an idea of how they're structured and what I mean by a science of physics being modeled after Euclid's elements, or of the modeled after the form of Euclid's elements. Then he proves that there cannot be motion over a finite distance in an infinite time, sort of the inverse of the previous. Then that taking the ratio of the swifter to the slower to be a sesquialter ratio, or 3:2, it is proved that lines or the parts of magnitudes cannot be indivisible. Again, proving the same thing, that a distance cannot be composed of indivisible parts. Then he proves that it is the same now, which is the limiting end of the past and the beginning of the future. And also that the now is without parts and indivisible. And along with that, the theorem that nothing moves at an instant or in the now, that there can be no motion in the now, but everything in motion moves in an interval of time. See, again, he uses Zeno's arrow paradox that disproved motion, that disproves the possibility of discrete motion or motion at an instant, is upheld. And Aristotle even provides a better and much more sophisticated version of that argument that doesn't really get mentioned. This is some of the best arguments that are found in Aristotle, at least as some people think. And aren't the sorts of things that would be objected to. I don't think. There are a few things in here. The second book regarding the difference between circular motion and rectilinear motion and the motion of the heavens, much of that would be objected to in the context of modern physics. But I make a defense of that. That's why there's included in this essay a defense of Aristotelian physics and a refutation of Newtonian mechanics. Specifically as to Newton's account of orbital motion. And this gets passed over too. That given Newton's premises, his first two laws, that a motion can only be altered rectilinearly, and that everything in motion continues moving rectilinearly unless it is altered again, in which case, again, it would only be altered rectilinearly. Given those premises, the curvilinear motion of the planets is impossible. And Newton established those laws for this purpose, to rule out that anything may be the cause of the curvilinear motion of the planets and the luminaries, regardless of the cosmological, which cosmological model. He still has to account for curvilinear motion, but he uses those premises. Those are his first two laws of motion because he wants to rule out there being any forces which can move things curvilinearly. He's trying to disarm the proof of the unmoved mover. But in doing so, he almost rules out there being any curvilinear motion. If a motion can only be altered in a rectilinear direction, and will keep moving in rectilinear direction unless it is altered again, in which case it'll only be altered rectilinearly. How can the planets move curvilinearly? And his maneuver is to say that their motions are altered in infinitesimal parts of time, or that their motions are composed of infinitesimal increments of a motion. That they're infinitesimal increment. A planet is always moving along a tangent. Its momentum is always along a tangent. And then its momentum is altered by the centrifugal force along another tangent, and then along another. But in infinitesimal increments, such as to compose a curvilinear motion, can every part of a curvilinear motion be rectilinear? There's certain conceptual difficulties there that are not, they're not unresolved, and they're problematic, to say the least. I thus provide a contention against that maneuver of Newton as a sort of defense of this second book that deals with circular motion, curvilinear motion as distinct from rectilinear motion. Because that is handled very, very sloppily by Newton. Infinitesimal increments. But this isn't the place for that. There is a good essay in which I argue those sorts of points in this book. Other theorems in the first book of this Elements of Physics Well, where we left off, the next one was everything that rests, everything that is at rest in an interval of time and not at an instant. That's sort of derivative of the theorem that disproves the possibility of motion at an instant. Then that everything that moves is divisible into parts. Then theorem 20, if all the parts of a motion are the motions of the parts of something continuous, also the whole motion will be the motion of the whole magnitude. All right. Then everything that has been changed when it first has been changed is in that into which it has been changed. Then that everything which has been changed has first been changed into some indivisible. These draw the distinction between changing and having changed. When something has first completed the change, it has been changed into some indivisible. When going from being changing to having changed and having completed the change, that change is at an instant, so to speak. The change is completed at an instant. But let's go on. Then there is no first part of a change in which a change begins. Or there is no primary time in which something has first begun to change. This is a sort of paradox. I said that Aristotle almost adopts most of the arguments of Zeno and somehow sets up a sort of science of proportionate motions in the resolution of those paradoxes, but then uses those arguments. Here, he presents a sort of paradox that something cannot have begun to change or that something cannot, a change cannot begin at an indivisible instant, else something would have changed some degree without ever changing. And nor could the beginning of a change be a divisible interval, because then it wouldn't be the first part of the change if the change would have taken place in both halves. Then the first half of the change would be the beginning. But if that's an interval, then the change would have taken place in half. Half the change would have taken place in half the time. And so neither would that be the beginning of a change. But if the beginning of a change is indivisible, then indivisibles would adhere, and something would have changed without ever changing, which is absurd, or which was already proved to be absurd. I hate to be brief without giving some of the arguments, but that would be tedious. I just want to go through, give a scope of what the subject matter is. Some of the other ones in the first book that are of interest, along the similar lines, this one, if the primary time in which a whole change occurs be taken, part of the change will take place in any part of the time. Primary time here doesn't mean the beginning of the change. It means the time that is neither more nor less than the time in which the whole change occurs. In part of the time of a motion, part of the distance will have been covered. Which is, these things are not, they're not easily objected to. They're not even, most people would not want to object to the first book of this, which really looks like a foundations of a science of motion. I don't see how this isn't enlightening as to what a science of motion, what the foundations of and the most primary arguments of a science of motion should even be about. Instead of electromagnetic fields, what does electromagnetic fields have to do with the sort of mechanics of motion? Or the slight curvature of a ray of light that can only suspiciously be detected, or that doesn't even count as a very good quote unquote observation, or whatever are the foundations of Einsteinian physics. I don't know, is that not the slight curvature of a ray of light? Can that be detected? Is that a first principle? Is that clear and distinct first principle? Is that a doubtless observation? Is that an observation? Or in the case of Newtonian mechanics, the first principles are that a motion can only be altered rectilinearly, and that something moving will continue moving in a rectilinear direction unless its momentum is altered, unless its motion is altered. Basically, he's saying that there is only rectilinear motion, or there are the only forces which can cause a motion are the same forces which move terrestrial objects by constraint. I think Proclus is vindicated, even in comparing and contrasting Newton's attempt at a demonstrative science. Proclus and Aristotle have as the starting points of their inferences the ideas of continuous, contiguous, and consecutive. Continuity, being in contact, and in sequence, one after another. What else is there in this first book of Proclus? Out of these 30 theorems, 31 theorems. Everything moving has already moved a part of the distance, meaning that if something is in motion, it must already have moved a part of the motion, or the part of the distance. Then that everything which has moved was previously moving. Some of these might seem obvious, or definitely not things worth objecting to. And then if there be something moved with which is infinite, it will not traverse a finite distance in a finite time. And if there be something infinite that moves, it will not traverse an infinite distance in a finite time. And everything which moves in place comes to wholly occupy a definite place, such as to be there only in the now. That is derived from that previous theorem, and not for any interval of time. Then the last theorem is that nothing indivisible can be in motion, a point, an atom. Much of this book is against atomism. A point cannot be in motion. That's the last theorem of the first book. Then the second book concerns the circular motion of the heavens and establishes that their motions are eternal and the existence of the unmoved mover, which is also eternal. This book is a bit more contentious and would be objected to by modern physics generally. We find theorems such as these: that bodies which move in a circle according to nature and not by constraint are simple bodies and are not composite or composed of the elements. Here I should say something. When Newton's first two laws are obviously drawn from speculations that are outside of his Principia and are not established by proof. There are certain arguments from Galileo, but this is where some of the contention rests. Galileo argued that a body in motion, a luminary or a planet in circular orbit, always has a momentum along a tangent. He argued that if you swing something around on a string, the body at the end of that string must have a rectilinear momentum at a tangent to the point of the circle at which it is at. Because if you cut the string, it'll continue moving circularly. Now, that may be the case for motion by constraint. But Aristotelians did not think that the heavenly bodies were such as to be impelled by the very nature of the sort of substance they are in any other direction than circularly. If you tie a rock on a string and swing that around, its momentum indeed may be along a tangent when it is moving when it's being moved by constraint curvilinearly, because it is a sort of body which doesn't move circularly or curvilinearly by nature, which isn't the kind of substance which moves that way. Just as fire moves upwards, not because it is pushed from without, but because of the very substance it is. As fire, the upward motion of fire is natural to that sort of substance. Similarly, this curvilinear motion of the planets and the fixed stars were seen as not being impelled by an external force, and so would not have momentum along a tangent of their orbital path. Nowadays, I have much contention with some of these foundational issues of Newtonian mechanics in Galileo that I'm not sure were was resolved with the sort of finality which they're assumed to have been resolved with. Thus, this first theorem, that bodies which move in a circle according to nature and not by constraint are simple bodies. Theorem 2. The bodies which move naturally in a circle are neither of the same kind of body as those which move rectilinearly, nor as those which are composed of them. And the next theorem, that bodies which move circularly according to nature have no share of heaviness or lightness. And theorem 4, that circular motion is without a contrary, from which he proves the next theorem, that bodies that move naturally in a circle are neither generated nor corrupted. I should say that I provided quite a bit of support where the theorem and the proof is given, and then often I provide an alternate version of the proof. Like with these, that circular motion is without a contrary, although also with the previous ones, such that there cannot be motion at an instant. I provide another version of the argument as well as the version of the argument we find in Aristotle. That circular motion is without a contrary is one which I provided, I think, more than one or two other versions of the argument. I reformulate the argument because that is the point which would be contended against. I'm therefore defending these positions. That circular motion has no contrary, that there is there is no motion contrary to circular motion, not even the reverse circular motion is the point at which an objector would contend against. That is a point which would be objected against. So I make sure that that argument is formulated in an airtight manner. For Galileo objected to that argument. But as you will find, circular motion cannot have a contrary. For contrary motions are to and from contrary places. Circular motion is to and from the same place. And if the reverse motion along the same circle were contrary to a given circular motion, then they would have to be to and from contrary places. But a circular motion is not to and from any contrary place because it moves past any point along the circular line. There's no end of a circular line. A contrary is an extremity beyond which the line does not continue and a motion cannot continue. But there's no point on a circular line beyond which a motion along that line would not continue. There is no point on a circle, which is the extremity of the circle. Neither is there a point along a circular motion beyond which the line cannot, the motion cannot continue, and which is an extremity of the motion beyond which it can't continue. And from that, he proves that bodies in motion in a circle, bodies that move naturally in a circle, are neither generated nor corrupted, or they would have to be generated from a contrary and corrupted into a contrary, as the elemental bodies which move upwards and downwards. As all rectilinear motion is to and from contraries. But circular motion is not. Since rectilinear bodies which move rectilinearly, the elemental bodies, are corrupted into bodies with contrary motions, there cannot be anything from which or into which the heavenly bodies were generated, nor into which they can be corrupted. Then he proves that every magnitude which moves circularly is finite. He proves that the fixed stars must be finite, or that the heavens must be finite, or that the cosmos must be finite. Because if they're infinite, an infinite distance would be traversed in a finite time, which is impossible, as was already proved. Now here there may be some contentions about cosmological models. I discussed most of that in the introductory essay, which again is meant as a defense of Aristotelian physics. Now, further proofs are that the forces or the weights of bodies that are infinite in magnitude are also infinite. And that a finite magnitude cannot have an infinite weight or an infinite force. The forces of things moving with unequal speeds are inversely proportional to the times of their motions. Then that there cannot be an infinite weight or an infinite lightness. Then that an infinite cannot be acted upon by something finite. An infinite body cannot be acted upon by something finite. And neither can anything finite be acted upon by something infinite. Nor can an infinite be acted upon by an infinite. For these things hold no proportion, but they would. Theorem 14. The kinds of simple or elemental bodies are finite. Theorem 15. There cannot be an infinite perceptible body. Theorem 16. Time is continuous and eternal. I provide a reformulation of that argument too. Theorem 17. The circular motion of the heavenly bodies is eternal. Theorem 18. the mover of an eternal motion is itself eternal. Theorem 19, things that are moved by something else are always preceded by something unmoved that is not moved by anything else. This is a sort of proof of the unmoved mover. I provide 4 supplementary arguments in support of that. Along with, again, almost every one of these theorems has as a footnote Aristotle's formulation of the same argument. Then where I find it necessary, I provide my own reformulation of the same argument. Or if that theorem is of great importance, theorem 20, everything that is moved by something. Theorem 21, the first mover of the circular motion of the heavens is indivisible. Which in a way corresponds with the final theorem of the first book, said nothing indivisible can be in motion. The last proof of this is the unmoved mover, which moves the planets and the heavenly bodies, is indivisible and without parts, has no magnitude, cannot be in motion. That is the table of contents and the theorems which are proved, or which are accompanied by concise syllogistic proofs, sometimes almost geometric proofs. And there is also the introductory essay in defense of Aristotelian physics and in a refutation of Newtonian mechanics, or Newton's account of curvilinear motion by only rectilinear forces, and his use of infinitesimals to, on the one hand, refuse that that a motion can be altered curvilinearly, and on the one hand, to claim that something can only be moved rectilinearly, and on the other hand, in order to account for the obvious curvilinear motion of planets, which is in contradiction with his first 2 laws and premises, in order to account for that, and as perhaps you may think, to avoid the contradiction, to say that their motions are altered from one tangent to another tangent along the circle in infinitesimal increments. But then I ask, are those infinitesimal increments of any span? What is an infinitesimal? First of all, that's not a clear and distinct idea. Secondly, if they're of any span, then each of those tangents along which a planet has momentum and is moved will be curvilinear. But a motion will be rectilinear. If those infinitesimal increments are of any span, they will be rectilinear motions. But a curvilinear motion cannot be composed of rectilinear motions. So every part of a curvilinear motion can't be rectilinear. And if they're not of any span, if those incremental increments along which a planet is moved are not of any span, are not of any distance, then their motion will be discrete. For their motions can only be altered rectilinearly. And they are only moving over a rectilinear distance, or only have momentum rectilinearly along a tangent for a point, if those tangents are not of any span. They'll then be moving at different directions at every point of the circle, and motion will be discrete. That is impossible. Thus, even in unraveling Newton's meaning of what is meant by an infinitesimal increment of a motion, we come to the true foundations of physics. For those questions ultimately lead to whether or not things continuous are infinitely divisible or not. Thus Proclus is vindicated. Thus Aristotle is vindicated. For those are the very principles of their science of motion, continuity, contiguity, or touching, and consecutive, or in sequence. And I will perhaps provide a second video that shows the structure of the first few theorems, that shows how the arguments are made and what those theorems sort of look like. What's their sort of form? But anyways, you can find this work on Amazon titled The Elements of Physics by Proclus and translated by Christopher Lawrence Winn. That is available on Amazon, and I think is something beneficial to those interested in Aristotelian physics and Aristotelian thought in general, in Platonism, in problems with the mechanistic philosophy and problems of science. Also for people concerned with epistemology. For though Euclid gives us one of the best examples of a demonstrative science, an axiomatic science, we don't see that sort of thing performed in other subjects, especially in physics. For Socrates doubted whether there could even be a science of change. Change being something that is not clear. None of these concepts are clear. Time. Time is something, one part of which no longer is the past, and the other part of which is not yet. Emotion being something which or change being something which is not what it was and is not what it is becoming or going to be. Thus, to make a sort of axiomatic demonstrative science out of the subject matter of physics makes for, at the very least, and in the simple fashion in which ancient philosophy is performed, makes for an example of what a rationalist project of physics would look like, a deductive physics. In terms especially of the questions of where the foundations of physics are, where the starting points are, what are the starting points and what is the end point, things which I don't think Newton considered, at least not from the standpoint of a philosopher.